Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and this is my co-host Nikolay, founder of Postgres AI. Hey Nikolay, what are we going to be talking about today?
Hi Michael, let's talk about planning time and what can increase it potentially.
Nice. And this was your suggestion. Why is it something you're thinking about at the moment?
Well, we are making circles around this topic all the time because basically almost all of our customers, which are mostly are like fast growing startups, they reach the point where partitioning is needed. They reach the point where log manager contention happens, number of indexes becomes concern, and also many of them still don't use prepare statements, mostly because PG Bouncer didn't support it until very recently, right? This means that planning time being basically unnoticed for quite long suddenly becomes an issue. And we often show them, look, like planning time is an issue in these cases. And this actually, especially partitioning thing is like there's always a question, especially for time series. It's always a question how big the partitions should be, which can be translated to how many partitions you will have, right? And if you partition not well, you may end up having many thousands of partitions. They will be very small, but if you don't have prepare statements, you can end up having a huge problem with planning time, and planning time can exceed execution time for simple primary key lookups, right? This is not fun.
Yeah, it's not the only case of that, right? But definitely makes sense that it's a common one.
Yeah. Basically, last week we discussed with a couple of companies how to properly implement partitioning. And this question was in the center, what size of partitions to choose. And the rule of thumb is like, don't let them be larger than 100 gigabytes, right? Because like this is like golden rule of partitioning. It's time to apply partitioning when you have risks already table exceeded 100 gigabytes, but it also can be applied to partitions. Also, they should be like balanced in terms of size. This is usually a good idea to do. But on the other end, if you like make them tiny, you end up having a lot of them, and it's not good. Why it's not good? Because of planning time, mostly. This is not the only reason why you don't want a lot of partitions, but this is one of the biggest reasons. If you have, for example, 10,000 partitions, you might have dozens of milliseconds or like maybe a second of planning time for each query. If prepare statements are not used, every time a SQL query is executed, planning is happening in Postgres, right?
Yeah, and you're talking about the best case. Planning time can expand depending on the complexity of the query. You're talking about for the simplest possible queries.
Very simple B-tree index scan.
Yeah. Is it worth us explaining what are we talking about? What is planning time?
Yeah, let's do it. So when query is executed, there are stages, right? Do you remember stages? Planning, it means the planner is based on statistics, and it considers the goal of the planning is to choose the best plan as fast as possible. It might be wrong. Very often it's wrong, actually. Not very, like it happens. It happens in like, for me, it's every day I deal with such cases because I see usually problems, not like ideal situations, right? That's like, this is when my team and I are involved when something is wrong. So it needs to choose as fast as possible the like kind of optimal plan, and then when plan is chosen, execution happens. Executor executes according to the plan, and there are like many possible plans. Many possible plans. Sometimes I think infinite number of possible plans, right?
Well, it depends, right? Like if you're doing a single table select and there's no indexes, then maybe it's only one possible plan. But once you include
what about
joins
parallelization? Already a couple of possible plans, right?
Yeah, but all I mean is as it gets important, like, for example, when you start joining multiple tables and you start to realize that you have multiple scan choices, multiple join orders, multiple join types that
Multiple
the optimizer
indexes
could choose.
are present. Planner needs to choose them properly. So yeah.
And these things are combinatorial. These things multiply to create the number of total possible plans. And it quickly, like as the number of joins, for example, increases, that can explode exponentially
Yep.
the time. So there are some things in Postgres too.
There's also a genetic optimizer, right?
Yes. So
the
because it can, well, I guess the simple version is that the planner isn't always looking for the best plan in those cases. It's sometimes looking for a good enough plan in a reasonable time frame. Because if we're taking way longer to plan the query, if we take multiple seconds to plan a query that's probably going to execute in a few milliseconds, it's probably a complete waste of time. So there's a balancing act here for complex queries. But for simple queries, it doesn't make sense to be paying dozens of milliseconds for a 0.2 millisecond primary key lookup.
Right. So the process of finding ideal plan is called optimization, plan optimization, and the planner deals with basically several things. First of all, decisions are of course heavily depend on the version of Postgres you use because all the time improvements are being made. Second of all, it uses statistics currently present in Postgres. So that's why it's important to keep auto vacuum tuned so it maintains the statistics. And this is not only PG statistic, it's also estimated number of tuples in Postgres rel pages. It's number of pages the table or index have. This is super important. And finally, it also takes into account the settings Postgres currently has. Interesting point, as I also mentioned many times, those who listen us not recently, they know it, right? Interesting that planner has no idea about real physical capabilities of your machine. It doesn't know what type of processor you have, how many cores, how fast disks are, or how many gigabytes of RAM you provided, right? It has no idea. It relies on the settings. First of all, costs, right? So random page cost, sec page cost, and so on, like CPU tuple cost and so on. And also settings like work mem and some estimate of available memory called the effective cache size. And you can put any number there, even you don't have those gigabytes of RAM. This is bad because if you forgot to tune your server, Postgres might not know that you have a lot of RAM, like terabyte of RAM, but Postgres still thinks you have only 1 gigabyte, for example. It's easy, to be in this situation, and it's bad. But at the same time, it's good for us who deal with a lot of experiments, because it means that we can fool the Postgres and say, we have same number of gigabytes as production has. And this helps us to reproduce the problem in lower environments when we have much weaker machine. This is great for experimentation. So good and bad. So that's it. This is everything what matters when optimization happens, when the planner chooses the plan the executor will be using. Right?
Yeah. Anybody that's familiar with Explain, I've had success describing planning time as the time it takes Postgres to come up with that explain plan. That's what it's doing. And you can even see this because by default, explain on its own doesn't show planning time. But if you do explain summary, so explain with the parameter summary, it will show you planning time as part of that. So it's quite a cool way of thinking of the. Yes, exactly. At the bottom.
Or if you ask executor to be involved and you run explain analyze, then summary is being turned on automatically, right?
Yeah, and you'll see the planning time and the execution time then. And the planning time is roughly the time it took to run explain on its own, and the execution time, in addition to the planning time, is the time taken roughly to run explain analyze. So that's quite a cool way of thinking about the difference.
Yeah, and worth mentioning, again, those who listen us for long know it very well, the word buffers. Since some version, like several years ago, it was implemented, I think Postgres 13 maybe.
You're right.
If you can use buffers, explain buffers even without analyze, only planning phase. And you can see how many buffers were involved into planning. And this is super cool because usually bad timing is because of a lot of IO, which is buffers, right? IO is number one reason why Postgres can be slow in anything, right?
Yeah. And you might think like, what's Postgres reading during planning time?
Yeah. Actually, you know what? I explained some picture, which is like maybe true in 99%, but I now remembered a case where something else was happening. It was some interesting query. I don't remember how many tables, but definitely it was a join, maybe a couple of joins. And I remember planning time was completely out of like normal. It was like half a minute or so.
I think I remember this case. Was it the
Yeah,
merge join issue?
exactly. Yeah, it was not
Yeah.
merge join was not considered the best plan. It was not chosen, but it was the reason why it was so slow. Considering merge join path, the planner used not only what I just described, but additional information. It tried to find minimum or maximum values for some subsets of data, edges, real values from table. So it needed to during planning time, it needed real values. And this, due to some reason, was super slow. So planning became many seconds, exceeding statement timeout and failing. It was extremely hard to diagnose, actually. And I
Do you
need
remember
to,
why?
yeah. Why? What?
Why it was hard to diagnose?
Because explain doesn't show other options. It shows only the winner.
Well, and
Right?
also extra reasons it was difficult. I believe I remember talking to you at the time. Auto explain doesn't show planning time, and therefore, when you're trying to
It's not a
diagnose,
problem for us because we didn't use it at time for this project. We didn't use auto explain at all, but we had DBLab engine installed, and I knew when these problems started happening, so I quickly rewinded, created snapshot and clone. So yeah, worked on the clone and reproduced the problem easily. Interesting that like 1 hour later it was different, and statistics changed somehow, and planner stopped considering merge
oh
join
wow,
path. Yeah, so it auto healed, but it was super scary. What happened 1 hour ago, right? But thanks to DBLab engine, we easily reproduced it. So I agree with you. Auto explain not showing planning time at that time. It was an issue, but not in this project particularly. What was an issue is you reproduced it. You see super slow planning time, but you have no idea what's happening, and you try to understand. If we had a way to see second best, third best plans,
yeah,
in
we've
this
talked
case,
about
we
this.
probably, yeah, second best probably would be merge join. It lost eventually, but during consideration of it, it was like Postgres planners spent a lot of time considering it because it needed real values. I think what helped in that case actually is, friend's advice, because Kukushkin first said, have you tried set enable merge join to off? Like what? Like this is weird. But once I did it, playing time went to almost zero. Like boom, it was interesting case. And of course, when you try to dig deeper, you can use like perf or BPF and understand what's happening under the hood and in which functions Postgres spends time, and you quickly find its merge join path, and then read the code because it's open source. This is cool. Read the code and understand that Postgres analyzing merge join sometimes needs real values from table. Wow, it was exotic, honestly.
Yeah, that is exotic, but it's also very helpful in understanding how the optimizer is working, because it isn't exhaustively calculating every plan that is possible, it can give up on plans if once it gets to a sufficiently high cost. So because the way enable merge join off is working, it's penalizing merge. It's not saying you can't ever have a merge join. It penalizes it cost wise, at which point the planner gives up on that.
Yeah, it discards very quickly because cost is already super high.
But I don't think that's how everybody thinks of how the planner works. They think it's going all the way to the end of each option, but it can abort early. And this is one of those trade-offs it's making. It will sometimes make a mistake because it seems like it's going to be an expensive plan, but then it isn't. So it isn't always looking for, in my opinion, the fastest plan. It's looking for a fast enough plan. Like that's quite like well, maybe I'm wrong in that. Like it is looking for the fastest, but it uses these shortcuts to avoid spending excessive time to do so.
Yeah, exactly. As usual, I like exotic and hard problems, but let's maybe switch to simple things.
Yeah, good idea.
Yeah, you sent me a very good post by Depeche, Hubert Lubashevsky, Depeche, right? And it was 3 years ago. He was curious about, is it really so that Postgres doesn't allow more than 65,000 partitions? And it turned out it's not so. He reached 100,000 partitions, right? But at the same time, Hubert checked the planning time. How exactly the planning time depends on the number of partitions. And this
is back to the initial question, the initial reason you were looking into planning time in the first place.
Yeah. We don't want a lot of partitions, many thousands of them, because planning time can be already like high, dozens of milliseconds, maybe hundreds of milliseconds, and so on. And basically, the growth is linear. And if you double the number of partitions, you double planning time, likely. So, of course, it depends on the query you use, I guess. But simple rule is just if you have a lot of partitions, you have bad planning time. It means we need to be... I also think Postgres versions matter a lot here. Many optimizations were made, right?
Well, I'm aware of one. So Depesh's test, he says that in the comments that he tested on version 14, which is important because there's a commit in version 15 a couple of years ago from David Rowley that says that's in the release notes, it said improve planning time for queries referencing partition tables. This change helps when only a few of many partitions are relevant, which is the case here where we're doing a primary key lookup. Like if we're just searching for a single row in a single partition, all of this, the 100,000 partitions, only one of them is relevant to this query. We can prune that at planning time.
Right.
In those cases, planning time should be much reduced as of version 15 onwards.
Well, I almost I use different table structure and queries, but it also was primary key lookup. But basically, I reproduced the same experiment using our AI system. And I'm just checking right now, Depeche had for 10,000 partitions, he had like 40 milliseconds or so, right? 30, 40 milliseconds. It's pretty much the same what we observed with our AI system. But I also used so-called shared environment experiment, so I was not alone on the machine. So that's why I involved buffers in my analysis. Because this time growth, linear time growth, according to my benchmarks, is explained by linear growth of buffer hits associated with planning. Yeah, so if you have 10,000 partitions, it might be several dozens of milliseconds. Yeah. So what do you think? What are you looking for?
I was looking at Depesh's post just to see if he gave enough details around how, did he pick the best of, sometimes when you're doing this kind of experiment, you would run the query a few times and pick the fastest or the average.
Several, yeah. I didn't. He used several, not many, I think 3 or maybe 5 runs only. I used only one run for now. I think it's a good idea to check, to convert this experiment to more full-fledged experiment, maybe on separate machine, and maybe even with PG-bench, and have many competing, like not competing, concurrent selects. The idea is it's again about buffers, many buffer hits for planning, and this explains the growth of planning time.
Yeah, I like how in your experiment, I like how clearly linear the chart with buffers is, whereas the one with timing, it looks like it might be linear, but there's enough noise that it's tricky to see. Although there are a couple of dips in the buffers chart, so there's something interesting going on there.
Yeah, I'm also interested, but and we also discussed before this call that it really matters. Is it first query when you just connected, or even not involving prepared statements? If you run the very first query, you have extra penalty because in this connection, information from system catalogs is not cached at all, and this adds extra buffer hits during planning time.
Yeah, that's what we thought it was. I don't know for sure, and it seems really interesting, like what it could be that's going on there. The reason I thought it might be that is I've seen in the past when running experiments, if I run analyze, like nothing to have explained in this case, just gathering new statistics for the table, I've seen planning buffers spike on the next query execution and then come back down on the second execution. So that makes me think it might be statistics related. But yeah, I've seen vacuum drastically reduce buffers as well. Not vacuum analyze, just vacuum on its own, and definitely not vacuum full. So whilst buffers are much more reliable and stable than timings for this kind of experiment, there are a few things that can affect buffers still.
Yeah. So anyway, I couldn't reproduce vacuum thing and analyze thing, but I can imagine if you have complex query, rebuilding statistics leads to many more hits from PG statistic, for example, of new data just collected. Especially if you have a lot of buckets, if default statistics target is increased and so on, like it's a lot of data to hit additionally. I don't know, like it's interesting. But anyway, back to partitioning, current recommendation would be let's not allow number of partitions grow to many thousands, unless we are okay with increased planning time. We can be okay with increased planning time if we use, first of all, pooler matters. So
yeah, true.
The situation when it's the very first query in session just established, it's very rare, right? It's good if it's really rare, and the pooler helps. Even application side pooler helps.
Yeah.
And second, of course, prepare statements just help us shave off a lot of planning time situations. Remember Dirk from IDN discussed problems. Even if you use prepare statements, still there might be interesting problems, and we had very interesting episode number 100, right? It was interesting discussion. So, but it's already advanced topic, and at bare minimum, it's good if you know planning time is going up. It's good to consider prepare statements, and Pitcher Bouncer supports them now, so it's great. And I must say, like dozens of milliseconds, it's already super slow overhead for planning. If we aim to have all queries fast for me means in all TP as usual. This is episode number 1. What is slow query? Slow query is if it exceeds 100 milliseconds, 200 milliseconds, because this is human perception, 200 milliseconds, when this is most people already see it's quite slow. And if one HTTP request consists of multiple SQL statements, this means we should be below like 10 milliseconds already. But if planning time adds 50 milliseconds, for example, if we have like 20,000 partitions, for example, wow, it's not a bad situation. It's not a good situation to be in, right? So prepare statements should be the good tool to fight with this problem, or just keep partition number low.
Well, a few times you've said, and I completely agree with you, that our primary server's CPU is our most limited resource, and planning time is CPU. Like it's a pure use of that, and if we can shave it, why not?
It's CPU, but I insist it's again buffers. It's just buffer hits. It's related to memory, but yes, it's CPU, yes, but still it's I/O.
Yeah,
I
no, you're
consider
right.
like I/O in a wide sense. When we involve communication to memory, also considered I/O. Not
Yeah.
disk I/O, of course, in this case. Most of the time, it can be buffer reads as well, but in rare cases. Sometimes we see buffer reads involved into planning as well.
You mean like shared read rather than shared hit?
Yeah, I call them shared
Yeah.
buffer reads because
Shared reads. Yeah.
yeah, we discussed it. Well, this I consider this bad naming because it's I/O operations, not amount of data. Right. Yeah. So,
Yep.
and what else? Indexes, right? If we have a lot of indexes, planning time is increasing also. And I suspect it's not linear even, but it's worth double checking. So if we have, for example, 10 indexes, that's some penalty, and planning time in a primary queue lookup can be already like 1 millisecond or so, half of millisecond. But if we go, like if our table has many columns, we are tempted to have dozens of indexes. And that's really bad. And it also, not only planning time increases itself due to buffer hits, again, buffer hits also grow here, but also locking. When planning happens, Postgres applies access share lock to each object involved. All indexes of a table are locked by access share lock. And this is like quite expensive, I would say. If you have like thousands of queries per second for this primary key lookup, it might be a problem, especially if you exceed 15 indexes, because total number of objects locked already reaches 16, which is threshold where when Postgres cannot, like above 16, it cannot use fast path for locking in Lock Manager anymore. And we discussed this as well. And
Is
this
it the number?
slows
Is that
down.
number being increased in the? I remember
I'm not
some
sure.
patched.
There are discussions to make these things configurable. Actually, I think I raised this question. It turned out not to be so simple. I'm not sure. I think in 17 nothing happened with this. So what helps here, like add more CPU, more cores, or decrease number of indexes,
Yeah.
or again prepare statements, right? Prepare
Yep.
statements. What else? What else helps in this situation when you need? Yeah, I don't know.
Maybe
That's
even
it.
denormalizing. If you've got a table with 15
Exactly.
indexes, why do you
Yes.
have 15 indexes?
Yeah.
Like,
Or this also helps decrease QPS of this kind. Caching on application side. If you had
yeah.
5,000 queries per second, I saw it I see it all the time. So every click an application reads from users table checking who is this.
Hmm.
Nothing changed. So cache it. Why are you reading this all the time? Or Rails, recently we discussed with one customer. Rails code is constantly bombing Postgres system catalogs, checking some PG class, PG attributes, and so on, like checking schema all the time, like thousands per second. Why? On replicas, like nothing changed. Like it's changing, but not so fast. So lack of caching everywhere, and this quickly can become a problem if you don't, especially if you don't use prepared statements again. But interesting that we can combine this problem and they can amplify, right? If you have, say, 10 indexes, it's enough to have like 3 partitions. Even 2 partitions is enough if you haven't checked partition pruning and some queries involve both partitions. You already have situation where like 22 objects need to be locked by access share lock, and lock manager contention might strike you. Jeremy Schneider had a great overview of
Yeah.
various works in this area from various companies. It's both about execution time, but mostly about planning time, because the planning time, these problems is worse because this is when Postgres locks all the objects. During execution, it locks only what is really needed. Right? So yeah, it's the worst case. You have partitioning, not many partitions, but also indexes, and then a lot of QPS, and it can put your server down completely because of lock manager, lightweight lock
Yeah.
contention.
Yeah. I think you've talked about like people doing the right, people who could be doing things for good reasons, still getting caught up. But I think there are also a couple of cases where, like around partitioning, people running a lot of queries without the partition key being supplied in them, like that kind of thing can. Like,
how to catch those situations? What would you do? How to verify that? For example, imagine we are prepared. We prepared already good partitioning approach, like with zero downtime conversion, everything.
Yeah.
And we need to double check that all queries will have partition pruning involved. How to check it? Holistically.
Good question. Well, actually, that brings me back to an idea. We've got pgstat statements, and we can now look at some planning related data as of version 13. It was a big release for planning.
By default, it's not on. You need to enable
why is it off?
Good question. And since it's off, many people, including actually myself, still have some fears that observer effect might strike you in some cases. So honestly, yesterday we discussed with one of our clients, we discussed that we should definitely consider enabling it. It's a good thing to have.
It would be good to hear what the observer effect is in that case.
I think we had experience checking this in synthetic with synthetic benchmarks, and it was very low, this overhead. But it doesn't eliminate, synthetic benchmarks don't eliminate all the fears, right?
Of course.
So I'm curious if people have planning time. Well, I know projects heavily loaded, huge clusters, planning time enabled.
So you mean pgstat statements .track planning on?
Not planning time, sorry. Yes. It's not only time, it's also IO, right? I mean buffers for planning phase. They are fine, but I'm curious about opposite, when people were not fine and decided to keep it off. Otherwise, I will call it another default bullshit, right?
And it's
we have a collection of them, like random patch cost or auto-locking settings.
I think this one's even worse because pgstat statements isn't on by default, so people already have to turn that on, and
they already agreed to pay overhead price.
Yeah,
right?
But also it means that in a default ship, like if Postgres ships by default, even if this parameter was on by default, it would be off still because pgstat statements isn't on. So I think this one might be one of the easier ones to change.
Yeah. Well, we need to check discussion. I might ask our AI to check what was discussion and provide summary. Good test.
But like you asked how to like monitor for that. I would expect to see issues there quite quickly.
Yeah. I'm interested in such issues. Yeah. So anyway, I agree. This is important. Observability for planning overhead, and
just P95, P99, like query latencies, I would expect to suffer.
But I think
if you're not
also, I have in mind in approach we discussed with a couple of clients actually over the last few weeks. If you enable partitioning, it's worth checking with auto-explain in lower environments, enabling it for everything, and just having it enabled and playing with like functionality. It's about testing coverage, right? If you cannot reproduce whole workload, of course, there are chances that you miss something, but it's good. Then you can just analyze logs and see if there are plans which involve multiple partitions. But you need to partition properly as well. You need to have multiple partitions for all tables which are partitioned.
Yeah, true. And if you were doing this and you had thousands of partitions, that would be a lot of information in the logs. And still no planning time information.
Yeah, but we are interested in plan structure in this case.
True.
And in lower environments, we usually, like if it's smaller database, for example, it's not thousands of partitions. For example, we say, okay, we want to have at least 10 partitions for each partition table, and then we just check plans, and with some analysis, we can analyze them. And it's a separate question how to analyze them, but anyway, we can holistically find bad plans. But I like your idea about pgstat statements as well. I wish it had, it had information about plans more, not only timing and buffers, but for example, how many objects were logged, for example, or involved into plan, or I don't know, like some additional things here. For example, just was partition pruning involved? How many times it was involved in plans? You know, there's a column called plans. How many plans, right? Yeah, partition pruning question, because partitioning is hard. It has so many surprising aspects, I would say. So many surprising aspects.
I have some sympathy with them. I think pgstat statements already has a lot of columns, and there's
yeah, I agree.
Still, so it is
not
difficult.
Enough. Yeah, still not enough. We have interesting work happening in the area of monitoring, and we discussed pgstat statements based, not only pgstat statements, but query analysis and holistic table of query analysis. It's so wide because we take every metric and have 3 derivatives for all metrics: time-based differentiation, calls-based, and also percentage, except column calls. For this column, we doesn't make sense. Calls per calls, it's always 1. So it's like 4 times more minus 1. It's so many columns to present. Yeah, we don't need them all the time, but I can find cases when some of them, like almost every one, is useful in some cases. So query analysis becomes harder and harder, wider and wider in terms of how many metrics we have. Yeah, and it's still not enough. That's it. So yeah, good. I think we covered this topic quite well.
I had one last question for you.
Yeah.
Do you ever change people's from collapse limit or join collapse limit?
Oh, interesting. I honestly, like last, for example, 12 months, I don't remember cases of it at all, somehow. In the past, I had cases when we considered it, and I think even applied it, but it was so long ago.
Yeah.
Somehow,
I think the default's quite good. The default for both of them is 8.
Yeah.
I think it works pretty well.
It works pretty well. And also, I don't know, like when I see 12 tables involved in plan, joins, and like I already like, oh, genetic optimizer already here, right? It has 10 or 12 threshold, no?
Yeah, I only learned this today.
Wow.
But I think because of from collapse limit and join collapse limit, Gecko never kicks in.
Wow. Okay. I have old memory. Okay.
Me too. Like, well, or maybe I misunderstood originally, but unless you raise those to above the Gecko threshold, this is my new understanding based on reading the docs. Unless you raise them above the Gecko threshold, it will never kick in.
Well, yeah. Somehow recently, I mostly deal with different problems when only few tables involved into plans.
Makes sense.
Yeah, but my experience is not everything, right? So I'm sure there are cases where collapse limits matter, like, and worth considering, but just didn't happen to me recently.
No, I was just interested from it's one of the things we look out for high planning time. It's one of the things we recommend looking at in case someone has tweaked them. For example, if somebody's increased them too much, that can massively balloon planning time.
Interesting.
But I wanted to know, like in the real world for you, is it something you see often? But it sounds like no.
Yeah.
Cool.
Well, there might be more cases we even didn't see yet. Haven't.
Oh, of course, always.
Always, yeah. So because the Postgres planner is complex, it's not as complex as SQL Server or Oracle planners.
Not yet, no.
Yeah.
Well, hopefully never.
Already complex enough, I would say. So yeah, good. Oh, by the way, if we use PG plan hint plan.
PG hint plan.
Right, because we tell the planner what to do directly. Does it help fight high planning time?
I don't know.
Good question.
It would make sense that it would, but I don't know where it's hooking in.
Yeah, I don't have this I don't observe it used in production at all, only in non-production. So I also don't
same.
know. Okay, good.
Question to our listeners.
Let us know if
you're... And also the other thing I wanted to ask is if anybody using some of the more complex extensions that hook into planning, like for
some
example,
extensions
Citus or
affecting
timescale.
planning.
Yeah, I've seen more planning time issues. Like it just feels like a coincidence at the moment. I haven't looked into if it's definitely the causal rather than just it's correlation versus causal.
Causation.
But yes, that's the one. So I don't know if it's just coincidence, but I tend to see more planning related issues with the more complex
Maybe
extensions.
some extensions help improve planning time, not make it worse.
Well, you mentioned PG Hint Plan would be the one that would make most sense on that.
Well, yeah, it's just a random guess. I'm not sure at all. Worth checking.
Me too. Well, let us know. If there's definitely people out there that know more about it.
So let's do summary. So try to avoid high partition number. Try to avoid a lot of indexes. Especially try to avoid this combination of these two problems, and use prepared statements. Right?
Yeah. You don't think avoiding lots of joins as well?
Maybe, yeah. Again, like somehow I deal with very simple plans lately. I don't know. Yeah, good point as well. Good point. You know, I try to avoid a lot of tables, many joins, and then like we try to expect good performance because like I always hunt for single index scan and better index only scan, always. And if you have even one join, even two tables, you cannot build index on two tables. It's always one, like indexes belong to their tables always, right? And materialized views, as we maybe talked, out of scope for my recommendations, always regular materialized views. So that's why I tried like to think how can we simplify things and okay, nest loops and so on, like, but and make queries sub millisecond. But yeah, if many tables, planning time might be huge. Anyway, I wanted three lessons, like low index number, low partition number, but not super low. So partitions should be small relatively, and prepare statements. I think these three might take years to implement in large projects.
Yeah, true.
Yeah, unfortunately.
Cool. Okay, nice one, Nikolay. Thanks so much.
Bye-bye.
Catch you next week. Bye.